Hi guys, welcome back. Talking about graphing radical functions here. Specifically, we're just going to work on square roots because that's probably all you're going to see in Algebra 2. Remember from the last video that the most important thing is finding the location of the start of my graph, which is 0, 0. So if I can locate that point, that's like what we did with parabolas and locating 0, 0 for a parabola, and we decided, hey, you know what? If I can find that vertex of a parabola when I slide it around, that's 99% of the battle. So here we're going to translate it, and we're going to say if I can find 0, 0 for a square root function, then that's 99% of the battle. And so what we do is this, same idea holds. You might remember that if I did x squared plus 2, if I added 2 off on the end and it had nothing to do with the square, that moved it up 2. Well, this is going to do the same thing. See, this plus 2 is off at the end. It has nothing to do with the square root. It's not being square rooted itself, right? And so all I do is I shift everything then up 2 units, okay? And so I would start instead of 0, 0, I start at 0, 2, right? And now, if I remember correctly, it's like a parabola, remember from the last video, and I'm going to turn it sideways. I'm going to go over 1, up 1, over 2, up 1, 2, 3, 4, over 3, and up 9, and I have the dots for my graph. The problem is that I know many of you are not going to be comfortable with what I just did, okay, because that's kind of a tough concept, right? And so the easier way to do it, I feel like, and a way that I would encourage you to do it is just to use a t-table, okay? For instance, if I put 0 in, once again, I know the square root of 0, so I'm going to choose that. And I would have square root of 0, 0 plus 2 gives me 2 for the coordinate, 0, 2, first dot. I know the square root of 1, so let's choose that. And the square root of 1 is 1, plus 2 gives me 3, 1, 3, second dot. I know the square root of, not 2 or 3, but I know the square root of 4, so I'm going to choose that. The square root of 4 is 2, and 2 plus 2 is 4. And I know the square root of 9. The square root of 9 is 3, and 3 plus 2 is 5. And you can see that the same dots get graphed here. 0, 2, 1, 3, 2, 4, 9, 5, and I still get the same graph. So, use a t-table if you want to, all right? Over here, if you remember correctly, whenever I did something like this with parabolas, we knew that was left 2. It's the opposite of what we're thinking, right? We always think left and right. You think plus 2 is right 2, but it's not. It's the opposite, left 2. And so this is going to do the same thing. All it does is it moves it left 2. So my first dot is right here. And then I would go over 1, up 1, 2, 4, 3, 9, so on and so forth. But once again, you could always use a table, okay, and just graph this. Now this is a little bit more complicated. If I put in a 0, that gives me 0 plus 2, and I don't know the square root of 2. So that's not really a convenient value. I think the most convenient value would be what gives me a 0 in the end, okay? And if I put a negative 2 in, that gives me negative 2 plus 2, which is 0, and the square root of 0 is 0. I know that the next important point is like, how could I get a 1 out of this? Because I know the square root of 1. I would have to put in a negative 1 for x, because then 2 minus 1 is 1, and the square root of 1 is 1, right? And so negative 1, 1 would be my next point. And the next square root that I know is the square root of 4. So how could I get a 4 out of this? I'd have to put a 2 in for x, right? Because then I'd have 2 plus 2 is 4, and the square root of 4 is 2. So 2, 2 would be my next location. Next thing I know is 9, right? So how do I get a 9 out of this? I'd have to put a 7 in for x. And if I put a 7 in, I get 7 plus 2 is 9, and the square root of 9 is 3. 7, 3 is going to be the next location here. And I can see that square root graph starting to form. I could have done like this and turned it and gone 1, 1, 2, 4, 3, 9. Both of them are options. I really don't care how you get to the answer. I just need you to get to the correct answer, okay, and be able to graph this thing. Let's do one more. We'll do 2 more here, okay? What if I have a negative sign out in front? All that does is it says, okay, whenever I form my t-table, that I have the square root of 0, square root of 0 is 0, but then I throw a negative sign out in front. Well, that's the same thing. 0 is not really positive or negative, right? But if I do a 1 here, then I have the square root of 1. Notice the negative is outside, so it's not imaginary numbers. It's a negative on the end after I do the square root, okay? Square root of 1 is 1, but now it's going to become a negative 1. So I go over 1 and down 1 instead. If I put in a 4, the square root of 4 is 2, but now it becomes a negative square root of 4, a negative 2. So I'm over here instead. Whoop, I missed it by a spot. Okay, so 4, negative 2, 9, negative 3 by that same pattern, right? Hopefully you're seeing this, and really all it did then, we can see that it flipped it upside down. Similar to how when we did negative x squared, we said it reflected across the x-axis. Same thing here, right? So this is a reflection across the x-axis. The last problem I'm going to do, I'm just going to show you, instead of doing it by hand, I'm going to show you on the calculator what it might look like, okay? So if I did 2 times the square root of x, I just want you to know that I can always go here and I can type 2 times the square root of x in the square root, okay? That's important that you enclose everything inside of it within parentheses. And when I go, I could use the table here. It doesn't like, oh, let me do my table setup. Let's start at 0, and let's go by ones. And let's go back to the table. And you can see here that 0, 0 is my first point. And now you know what I'm going to do? I'm going to only pick the values that are nice, neat numbers. So 0, 0, 1, 2 would be my next point. 4, 4 would be the next point that I'm going to use. If I keep scrolling down, let's see if I get any more before 10. Oh, look at that. I know the square root of 9, but now I get a 6. Okay, so 9, 6 is a point. So I'm all the way up here. And so my graph looks like this. And you remember how we widened out our parabolas or made them skinnier? We did basically the same thing here. We're saying that, you know what? Instead of, all I did was I took 0, the square root of the thing I know is 0, times 2 would still be 0. 1 is a square root that I know. The square root of 1 is 1, but now I double it and it becomes a 2. The square root of 4 is the next value I know. The square root of 4 is 2, but now I double it and it becomes a 4. The square root of 9 is a number that I know. It's 3, but now I double it and it becomes a 6. So once again, t-tables are the easiest way to do this as opposed to transformations with radicals. You can remember the rules if you want to about reflecting across the x-axis, about doubling the height, about moving it left 2 locations, and about moving it up 2, but you'd also have to be able to take your paper and turn it sideways and go over 1, up 1, over 2, up 4, and that kind of thing. Okay, so a little bit confusing. I'd recommend the t-table. Hopefully this is enough to get you through the homework. I think it is. You have time to practice in class, and we're done with this unit after this.